Got it.
I needed to click something on the monitor.
Okay. Can you let me share the screen?
Will do. I'll set your schedules as well. Make sure that we get all the. All right.
Stop one. There we go. All right. Well, welcome everyone to the last day already of the Venus University workshop. So what we're going to do today is essentially talk about a step that so far we've skipped, namely what to do with the data once you have collected data for your experiment. And as always, all the slides by now, all the slides also for today are on the workshop website. So before the break, what we're going to do is we're going to first take a look at how you can prepare data from online experiments, so the ones that you've collected in JTOS. Then we're going to take a look at how you can prepare data from lab experiments, so ones that you just collected in the lab by running OpenSesame on the desktop. These two forms of experiments require slightly different steps to actually get the data into one big data file. Then we're going to take a look at how you can convert data from so-called long to wide format. These are, well, we'll talk about that in a bit, of course, but essentially we're going to focus on one specific type of statistical analysis, a repeated measures ANOVA, which is a sort of traditional way to analyze within subject experiments of the kinds that we've talked about here. This is only one of many kinds of analyses, and we can discuss also other approaches if you're interested and if we have time. But that's what we're going to focus on. And then that's what we're going to do before the break. I will first give you a demonstration of how to do things, and then I will sort of encourage you to actually go through these steps yourself. The end product basically of the workshop before the break will be a nice big data file that you can analyze. Then after the break, we're actually going to conduct a statistical analysis in the program JASP that I sent you an email, or Vishnu sent you an email about this morning. And then we'll have a Q&A session and the workshop ends. And this Q&A session will also be a good moment to basically ask questions about the things that you have been working on, right? Your own experiment. So if there are sort of outstanding questions right now, this would be the moment after the break to ask me. And then we'll end the workshop, and we're not going to have a very strict end. So basically, if there are still questions at 5 p.m. your time, then it's okay if we continue for a bit until everyone has had a chance to ask all the questions that there are. And as always, interrupt me at any moment during the talk. So let's start with preparing data from online experiment. I'll walk you through the steps first here. And then I will actually show you how it works. So if it goes a bit fast, don't worry, you will get a second chance when I actually show the actual process. So when you conduct an online experiment, the data is stored in JTOS, so on MindProbe, the server that we've met already during the second day of the workshop. And there is a results section, you click on it, and then you see a big table essentially of all the data that is collected in the online experiment. And each session, so each moment that someone started the experiment, that's what a session means in this context, is one entry in this results table. You will see that every result has a status. I kind of awkwardly did not put the status here in this screenshot, but all the way on the right, you will have a status. And the status can be finished, and that means that that session was completed from start to finish without any kind of error. So that's the ideal. You can have a fail. This means that an error occurred, for example, because there was a bug in your experiment that made it crash, but it can also mean that the user actually aborted the experiment by pressing escape. Then you have data retrieved and started, which means that the experiment has started, but it hasn't finished yet. So JTOS doesn't know whether it is actually still running, or, and it can also happen, of course, the experiment just vanished, for example, because the browser was closed, something like that. Basically, a start signal was given, but no stop signal. There are two different statuses, data retrieved and started. I don't know what the difference between them is, to be honest. Now, what you will see is that if you conduct an online experiment and you, unless perhaps you do it in an extremely controlled way by sending individual links to participants that they have to finish, but if you do it kind of the way that I do it, with general worker type that everyone can click on, then having a lot of non-finished results is kind of normal. It is, I guess it's a side effect of the way that people are used to doing things on the internet, right? People are very used to actually clicking on something and then clicking it away again. That happens a lot. So basically dealing with the data is also a matter of trying to clean out the things that are not finished, basically clean out the empty things. And also what happens quite a lot is that people get confused. For example, they click on the link, they assume that they go through the instructions. Perhaps they think that they can do the instructions again by refreshing the page, right? It's not even such an unreasonable thing to assume. And then they refresh the page and they actually really get an error because refreshing the page is not allowed during an experiment. That might also be another reason why the experiment is not finished. So even under reasonably optimal circumstances, there tend to be quite a few non-finished statuses. We will see that later. So, now, how do you then download the data from JTools? Well, the downloading itself is very easy because you can just say export results download and then we'll go to your downloads folder. But what you will get is a sort of a text file, and if you open it, it will look very messy, and it is actually really very messy. It is a text file that is sort of a JSON format, but it's actually also not really valid JSON. And it is hard to work with. Actually, the format of that file is kind of constrained by the requirements of OpenSesame, where you want to be able to send data every time that there is a logger item. And well, there are a few technical constraints, but the result of those constraints is that the data file itself is pretty ugly in JTools. The solution to that, fortunately, is very simple. There is a conversion button in OpenSesame, and then you basically take this JTools file and you convert it to a spreadsheet, either as an Excel file, an XLSX file, or a CSV file. And from there, you can just open it in Excel or Google Docs or open LibreOffice Calc, whatever you want, basically. Yeah. So that is, once you have done that, right? So you've downloaded the file from JTools, you've converted it to an XLSX file. Then you have a file that people often call long format. What does it mean? It means it's just a spreadsheet. There's nothing particularly complex about it, but it is a particular kind of spreadsheet where one row corresponds, generally speaking, to one trial in a trial-based experiment. Strictly speaking, it actually corresponds to one logger in OpenSesame, one logger call. But usually in most experiments, one logger call equals one trial. And then one column is one variable, right? So the response time, conditions, etc. Right? So in the screenshot, you see that there's a variable called circle X, indicated where a circle was shown on the screen. And on the first trial, that circle was shown on the X coordinates was -41. The second trial, it was 0, etc., etc. So that's the format of the log file. It's quite intuitive, but for many kinds of statistical analyses, actually not the kind of input file that you need. So that's why we will get to the conversion from long to wide format in a bit. But here, these steps are basically, so you have an online experiment, and how do you actually really go from the data in JTools to the kind of long format that you see here? And these are the steps, and we will see them in a bit again. Now, if you start from a laboratory-based experiment, then you need to do a few other steps to go to this long format. So let's go through those as well. So if you want to prepare data from a lab experiment, then you start with a different kind of log file, right? You don't start with JTools, but instead, for every participant, OpenSesame creates a log file on your hard drive, and they are separate CSV files. So here you see a screenshot of a data folder with 30 files, right? And they're called subject1.csv, subject2.csv, etc. Each of these data files by themselves is also long format. So one row in that data file is one trial, one column is one variable, etc. But it is split by subject because every subject corresponded, of course, to a separate start of OpenSesame, basically. So what you then need to do, if you want to go to this big long format data file that contains the data from all participants, you actually need to merge the data into one file, right? So you need to go from all of these separate subject CSV files, and for some reason, go from multiple participant data files and go into a single data file. Now, there are many ways to do that. And maybe you have your own technique. One very simple way, of course, will be just to copy paste the files and put them underneath each other, something like that. But you can imagine that that is very time consuming if you have 30 participant files. And it is also kind of error prone, because if for one reason or another, they don't really match in the kind of columns that they have, then of course this will not work. So I firmly intend actually to at some point create an extension for OpenSesame that basically does the merging, because it is quite an easy process to do programmatically, but currently it doesn't exist. So this is the only moment during this workshop where we're going to use a little bit of Python. And what I will do is basically show you how to copy paste the Python script from the documentation side and very slightly adjust it until it does the merging for you. So it will not require any kind of knowledge of Python, but that is, I think right now, the easiest way, even if you don't know how to do programming, to merge the data files. And then what does the data look like when you've done that? Well, it looks the same as for the JTOS steps. So the data is now again in long format, one row per trial, one column per participant, but now all participants are in one file, and that's it, basically. So those are the steps that you need to do for the laboratory experiment. So you go from multiple participant files, you create a short script, and then you go to one very long data file. Yeah, are there any questions up to this point about what it means to have a long format or about any of these steps? We will see them in a bit when I demonstrate them, but I wanted to ask you.
Yeah, so maybe.
So maybe I will mute myself. Can you say something, Vishnu? I will mute.
It's audio setup.
Okay, so the echo is not me, because I just muted myself. Maybe you can type it in the chat, and then I will.
How about now?
Yeah, perfect.
Yeah,
yeah.
Now it seems okay. So just to add for those of you who are probably not comfortable with Python scripts, so as Sebastian had said, it's going to be copy and pasting. But if some of you I know are working with R and more comfortable appending the data using R, I can also share a script to do that easily with you.
That's actually a really good point, Vishnu. Yeah. Okay, yeah, so let's talk a little bit. So far, I've been using the term long format, and long format contrasts with so-called wide format. And those are, well, long and wide format are different ways to organize data. So they're both spreadsheets, but they are spreadsheets in which the data is slightly differently organized. So long format is the most common format, basically. It's also what OpenSesame saves by default. But in some cases, statistical software expects a specific format, and such as the wide format. And then we're talking about, for example, when you want to do a repeated measures analysis of variance, or repeated measures ANOVA in JASP or in SPSS, then the software expects the data to be in this wide format and not in long format. Other kinds of statistical packages make different assumptions. For example, if you do a repeated measures ANOVA, correct me if I'm wrong, Wisnu, but if you do that in R, it actually expects it in kind of a long format, but a long format where every row is not an individual trial, but it is already the average of a subject and a condition. If you do a repeated measures ANOVA in stats models in Python, it actually expects the normal long format that I've just shown you with one row, and it will do some of the averaging for you. So you kind of need to know in advance what the format is, the data format is that your statistical analysis assumes. That is the bottom line, right? And there is no sort of overarching logic behind that. This is just something that is built into the software, and you need to know that, and you need to follow that convention of how the data should be organized according to the software. And this is sometimes a bit confusing, actually, and also the source of a lot of mistakes that people make in statistical analysis. Now, so what is this infamous wide format that I've been talking about? It is an aggregated format. What does that mean? It means that it's already the results of an averaging process. So we're going from a data file in long format that is really long and that has data from individual trials, and we're going to another format that is much shorter and that only contains data from individual conditions per participants. Yeah, okay. Vishnu says R also accepts the long format, but already aggregated. Am I right or not? Or does it also do the aggregation for you?
You need to do the aggregation as well.
Yeah, you need to, exactly. Yeah. And in this wide format, one row corresponds to one participant. You see that here in the screenshot on the left, on the right. And one column corresponds to one condition. So in this particular example that you're seeing, I will show you later how to reproduce that. Basically, it is a 2x2 design. So we have two conditions, target match and distractor match. They can both have the value 0 or 1. And then the result of that is 4 columns, right? With every possible combination of target match and distractor match. Is this a nice and elegant format? No, absolutely not. It's awful in many ways. But it is how JASP expects the data to be organized in order to do repeated measures analysis. And so does SPSS, and so does Statistica, if I'm not mistaken. So it is kind of a convention among graphical statistics software to do it like this. And then the cells correspond to the means of a dependent measure, the mean RT in this case. So this means, for example, if you look at my mouse now, I'm looking for subject 1, the average reaction time for the target match 0 and distractor match 0 condition was 1056 milliseconds. That's basically what it means. Now, where does this idea from this wide format come from? I'm not entirely sure, but I think that historically, a repeated measures analysis, as the name already suggests, means that there was one participant who had multiple measurements over time, so to say. And then, of course, it made sense to actually put the participant as a row and then have the multiple time points as columns, so to say. Think, for example, a pre and a post measure of some kind of medical testing or something like that. And then that format makes sense here, makes sense. And now we use the same kind of analysis technique to also analyze data from within subject designs with multiple trials. And now the format actually doesn't make a lot of sense anymore, but it is still used. I think that's kind of the historical background. Yeah, so how do you actually create a wide format? Well, of course, you don't want to manually do these averaging steps. So there is the concept of a pivot table, and that is a tool that is specifically designed to go from long to wide format. And it is available in every piece of spreadsheet software. So you can do that in Excel, you can do that in LibreOffice Calc, which is what I will use. You can do it in Google Sheets as well. Google Sheets actually is pretty nice as a statistics, as a spreadsheet software, and it has a really nice pivot table functionality in it. And they all work the same. So the idea from Excel, LibreOffice, and Google Sheets is the same. Programmatically, also in Python Data Matrix, you have a Python library that creates a pivot matrix. Pandas has a pivot table functionality. R can create a pivot table for you. So there are all kinds of ways in order how you can go from long to wide format. The general transformation tends to be called a pivot table. And what I will do is actually demonstrate it in LibreOffice Calc. All right, so with that, let's actually go to work. And with going to work, I mean, I will show you the steps that I've just been describing to you in verbally. And then afterwards, I suggest that you do this yourself on your own data set. So if you do not have data that you can work with yourself, we will provide some for you. But otherwise, otherwise you can, rewind. If you have your own data, then of course it's nicest actually to go through these steps with your own data because you know that best, and it's also nice to work with your own materials. But if not, I will post in the chat some files for you to work with. All right, so with that, are there any questions actually at this point? No, then up. All right, so I will log into MindProbe, and I will first show you actually the steps for how to transfer how to actually transform the data from the online experiment. So I have a lot of experiments here, right? So I can choose one. What shall I do? Well, you know what? Let's actually take a nice experiment in which the visual search experiment, or now I'm kind of up.
I just wanted this. Can people hear me now?
Yes, I think so.
Just wanted to add that this morning I sent Sebastian this file from our experiment that we did in February. So that is available as well. So I'm just going to put it in the chat.
Yeah, that's.
I want to use it for practices.
I didn't have time to actually look at the format. Otherwise, I would have used that myself now as a demonstration. But yeah. Okay, so here we have a visual working memory experiment that I actually conducted in Introduction to Psychology. What does the visual working memory experiment look like? Well, it looks like this. I can actually show you. That's the nice thing about doing an online experiment. Up. Basically, it is very simple. There's an arrow pointing to the left or to the right. Then there are these colors, and here you have to remember the one on the left. Then after a retention interval, they're shown again, but one may be different or the same. And if it is different, you press the right key. If it is the same, you press the left key. And that's about it. And then there are 64 trials. So it goes like this, up, right, it's the same. I think it's different, correct, right. I think it's different, correct, etc. Now, up, the same, well. So this is a working memory experiment, and the main and the dependent variable is whether you're correct or not. And the independent variables, the memory load, right? So you could have the number of circles varied from 1 to 4, and so it is a very simple design. Now, here we have 131 results, study results, up, and then I click on it, and then in JTools you simply say export results, and then I say all. I want to export all results. And then it starts downloading those results to my downloads folder. Right, so far so good. Yep. So then you see it here. These are the results that I just downloaded. Now, just to give you some idea of, just to show you what that looks like, before I start converting it to something that is more user-friendly. Yep. Here I have a text editor. This text editor is called, it doesn't matter, you can use any kind of text editor, but this text editor is called Rapunzel, and it is included with OpenSesame. It is basically the text editor version of OpenSesame. In OpenSesame, if there is in the toolbar, there's this kind of button that is kind of darkish with bluish, greenish, reddish colors. If you click on it, and it looks like a text editor, if you click on it, it will launch Rapunzel, basically. So this is what the data looks like. is you download it from JTools. So you see that there are, right, you can see there is a changed variable, yes, whether it was correct, yes, lots of things. There's also a set size for, so you can kind of see that all the information is here, but it is not really the kind of format that is very nice and easy to work with, right? So in that sense, the data is there, but you don't directly want to start analyzing this text file. Instead, what you want to do is open OpenSesame. Up, here we are. And then under Tools, OS Web, you have this conversion, convert JTools results to CSV XLSX, this option. If I go to my downloads, I simply select that file. And then I have to say, and I say, okay, visual search data .xlsx. I save it up. And now if I go to my downloads folder, I have this here. Of course, for you, depending on your operating system, everything will look slightly different, right? But under Windows and Mac OS, it will approximately work everything the same way. Now we have the visual search data as an XLSX file. And if I open it up, you see I have this very nice long format data file. It is really big, right? So I have 3052 files, trials. Up there are lots of variables, but we are mainly interested in the set size variable, this one here, and whether they were correct, this one here. Up. And what we're also interested in is we need to indicate what the study ID was. What does that mean? Well, it means basically, let's see, did someone raise a hand? Participants? Or no. So we need to somehow group the data together, right? We need to be able to say this is participant X, then this is participant Y. And for that, we can use the JTools study result ID, which is basically an arbitrary number that is assigned to every participant. That's what it means. Okay, so this is the log file, right? And how do we actually go from this to some kind of data format that we can use for an analysis in JASP? So how do we go from this long to a wide format? Well, we can do that by saying tools, and it will work slightly differently if you use Excel or Google Sheets, but the idea is exactly the same. Whereas, data, and you see there's a pivot table option, and I simply say insert pivot table. Then I say, then it asks, what should I base the pivot table on? Well, you should just base it on the current sheet, right? So the default is fine. Just use this sheet as the pivot source of the pivot table. And then if I press OK, up, it will actually give me some options for the pivot table. Now, what does it mean? So the row fields is basically, right now the pivot table needs to know how to organize itself. So it needs to say which kinds of different things need to be in the rows. And we know that the different participants need to be in the rows, right? That's what the data, JASP expects. And then we need to know what is actually the variable that defines the participant. Well, in JTools, because we don't really have unique subject numbers, we need to use the JTools results ID, which is sort of the unique identifier for every JTools session. Up. JTools study result ID. In the columns, it selects data for some reason, but that's not what we want. The columns should be the different set sizes, because that's the independent variable, right? So we want to have participant as rows, set size as columns. Up, column field set size, and the data, that is our dependent variable. So that is basically what is aggregated in these data, aggregated in the cells. So, and for that, we want to have correct, because what we're interested in is the mean accuracy. So the correct goes to the data. Then by default, it says some data. That's of course not really what we want. We want to have the average of the correct, right? We don't want to have the sum, but the average. Now, if we do this, this in principle will work. So we will get a nice spreadsheet. And you see that there are 44 participants, basically, or well, not 44, but this many participants. So 41, because we start counting at row 3. And for the set size 1, this is the average accuracy, set size 2, set size 3, etc. However, what we're still kind of missing here is basically that we don't, this also contains data from participants who only partially completed the experiment. So it would make sense actually to also include information about how many trials every participant actually did, if you see what I mean, because that is kind of useful to know. So what we can say, okay, edit this pivot table, and then what you can say, okay, instead of I will also include the count of the correctness, because that includes how many observations there actually are. And now you see that the pivot table becomes bigger, because for every row there's not only an average but also a count. And you see that basically lots of the participants have 16, that means that they completed the entire thing. But some participants actually have only one, right? This one and this one. And you see that for the empty, basically those are the participants where there is no JTOS results ID for a technical reason. And you see there are also 157 trials for which we actually don't have any JTOS results ID. So this is messy data, and you will get that from online experiments quite a lot, right? That basically you have data that is missing, or you're not entirely sure what kind of participant it comes from. But essentially what we want to do is take this pivot table and only keep the data that is useful to us. That is the idea. So for now, I'm just going to leave this. I will save it. And then after the break, we're going to see how we can take this data and put it into JASP. But for now, I'm just going to leave it as a demonstration of how you can go from long format to wide format. So is everyone with me so far? These are a lot of steps. And for some of you, this may actually just be repetition of stuff that you're used to doing anyway. And for some of you, this might be completely new. So give me a thumbs up if you're with me so far, actually. Yes, I'm using LibreOffice indeed, which is a free Office suite that basically I use instead of Excel. So give me a thumbs up if you're with me, and don't hesitate to ask questions if you have them. I see some hesitant thumbs up. All right. Okay. All right, so now we've gone from our JTOS results set to our pivot table, but it's a pivot table for a pivot table that we can use later in JTOS. What I want to do now is essentially the same steps, but then do it for the subject, for the laboratory data. So the same trick, the same output, but then for the lab data. So I close this, save, yes. All right, and now, as I actually said, I will demonstrate here in OpenSesame. You have this button, the button that says Launch Code Editor. That's what I will do. I will click on it, and that will launch Rapunzel, the same code editor that you saw before. And you can do that too in OpenSesame. Of course, you can use any kind of other code editor as well, right? You can use Notepad+, you can use whatever, Spider, RStudio, anything that edits text files, basically. And then I created in my downloads folder, which is already opened here in Rapunzel. I'm looking at my downloads folder. In the downloads folder, there's a subfolder called subject data. In it, there are 38 data files with subject data. What do these data files look like? Well, if I open them as text, you will see they are basically just regular CSV spreadsheets that are text files that are formatted in such a way that you can also open them in a text in a spreadsheet editor, right? So the first row consists of all the columns that exists, and then all subsequent rows are the values of those columns. So if I open subject1.csv in LibreOffice, it will do so, and you will see that it actually accurately recognizes that there is one row with columns and then these, right? So those are two different ways of looking at the same file. It is just a text file, but if you open it in Excel or in LibreOffice, it will actually be parsed into a spreadsheet. And actually, Excel doesn't really do that very well. So you sometimes have to say, I need to format this data as a spreadsheet. If someone gets stuck there, let us know, then we can help you. Okay. Now, and the thing, what we want to do now is go from all of these 38 subject files to one very big subject file with that is basically just all these subject files concatenated. And as I said, I will just use a very simple Python script to do this. And I will get that Python script essentially from the documentation side. So I will go to the OpenSesame documentation site, osdoc.coxsite.nl. I hope this site is familiar for you by now. And then under manual, there is an entry called data logging, and that contains a lot of information about data. So I click on that. And then there are sort of descriptions, but the one thing that is interesting for our purpose now is merging multiple data files into one large file. So I click on that. And then here, there is a piece of Python code that is already kind of made for us, already kind of ready to copy paste and use for this purpose. Right click, copy. I switch back to Rapunzel. Where's Rapunzel? Up. And I create in Rapunzel, I create a new file. I call it merge data.py, right? So I create a new Python file. I open it and I copy paste this code that I took from the documentation site into this text file, right? So I did nothing special here. I just right clicked and I said, create a new file. I called that file merge data.py and I copied the contents into that I took from the documentation site into it. You don't need to be able to program in order to do this. So let me walk you through what the script does, so that even though if you don't know how to program conceptually, you understand how this works. This is a Python file, a Python script. And it starts at the very top by importing a few libraries that we need. Importing means, okay, there is some functionality that we need to use in this script, and importing means make that functionality available in this script. And that functionality is basically some stuff having to do with looping over files, OS, and some things for reading and writing and operating on spreadsheets from data matrix. Then it says, okay, source folder is now student data. Change this to the folder that contains the CSV files. So for us, it's not called student data, right? But it's called subject data, actually. So that is what we need to change. So I call this subject data. Then we have changed this to a list of column names that you want to keep. So we're already kind of narrowing down. We're doing actually two things at once here. We're taking all the data, merging it, but at the same time, we're also removing columns that we're not interested in, because that's what people very often want, because it keeps the data a little bit cleaner. So then we need to decide, okay, what are we interested in actually? Which columns do we want to keep? So let's switch back to, let's open the file again, subject1, and let's say, what do we want to get? Well, there are so many files, right? There's a huge data file with so many variables, with lots of stuff that we're not interested in. And I know I conducted this experiment, so I know what kind of variables we're interested in. And in general, of course, there is no magic recipe that will tell you what variables you are interested in. You need to know that because you made the experiment. Now, I happen to know that I want to know, there is a subject number that I want to have. there is a correct mouse response that I want to have. And there is also a response time mouse response that I want to have, because we use the mouse response to collect a click in this case, and it could be correct, and we wanted to be interested in the response time. And there is a target match variable that I'm interested in. And there is a distractor match variable that I'm interested in. So I know, because I made the experiment, which variables I want to have. And those are the ones that I'm going to keep in the script. So I go back to Rapunzel and I say, well, the columns that I want to keep is subject number, of course, because that is what defines the subject number and what we need to split our data by. We want to have the correct mouse response, because that indicates whether participants were correct actually when they clicked with the mouse in this experiment. The response time mouse response, because that indicates whether they were correct also with the response time. We have a target match and a distractor match. What does this mean actually? Let me actually also explain, because then it becomes a little bit less abstract. So the task here was for participants to perform a visual search task where they had to indicate the identity, where the line of the orientation of a line in a target, and they could be correct, and then correct mouse response would be 1 or incorrect, and would be 0. This would be the response time of that response. And then we had 2 independent variables, target match and distractor match. The target match indicates basically whether the actual target that they needed to respond to matched something that they kept in working memory. So they should be faster, that's the idea. So basically facilitation. And this indicates whether the distractor that they matched something that they keep in working memory, and that would make them slower. So we had one factor that would make them faster and one factor that should make them slower. That's the idea. Okay, and then here, so we specify the columns to keep, and here we have a script that creates a data matrix, which is a spreadsheet, basically a programmatic spreadsheet, that loops through all the files in this folder that we indicated, reads the file, keeps only the variables that we're interested in, the columns that we're interested in, and then concatenates the small participant file to the big file, and then writes the results to disk as a new file called merge data. You don't need to understand the details, right? But conceptually, that's what this file does, what this script does. So what I did is basically, I just pointed it to the right location, subject data, and I indicated which columns I want to keep. That's the only thing that I did. Other than that, I left the script the same. I click here on the play button to actually execute the script, as though you would execute an experiment in OpenSesame, but now it's actually a script. Up, it runs it. You see here down in the bottom, it indicates basically that it's actually executing script in a Python console. And now you see that there is a new file, mergedata.csv. And if I go up, here's the mergedata.csv. If I open it, you will see it is a very, very big spreadsheet, you know, with no less than 10,000 trials of those 38 participants. Now, then we want to do what we did before, namely conduct a pivot table. So I again say data, pivot table, insert, current selection, and I repeat mainly the steps that I did before, right? So the rows should be the subject number, the data is actually the response time, that's what we're mainly interested in. The columns should be our independent variables, so target match and distractor match. And then we can do something that's kind of sweet, actually. We use also the filters thing here. So what you can say, okay, I want to filter based on correct mouse response. And that means that later I can say, I want to only get the response time of the correct trials, because that is what very often people want to do. You can also have more complex filters, right? So that you only want to have the correct trials that are faster than this kind of a timeout, something like that. And here for the response time, of course, I don't want to have the sum, but I want to have the average. And I also actually am going to do the count so that I know how many trials all the participants did. And then I say, okay, and we get the pivot table just like before. And now you see, right, so we have the average up. For some reason, it puts the count on a different line here instead of a separate, I don't know why, up. And you see, in principle, all of that looks good. But you also see that one participant here, participant 6, actually only had 65 trials here, so didn't really complete the entire experiment, right? So we need to actually discard that participant when we're going to analyze it. And here for the correct mouse, you can say, okay, this is all, but I want to have only the correct responses. So I'm going to filter by correct mouse is 1. It means that I only average the response time over the correct responses. Okay, up. And then you see that works. Basically, you see that the counts go down, of course, and that's normal because participants make a few mistakes. And you see actually was that here participant 2, oof, right? Oh, almost everything is incorrect here. So that participant needs to be excluded, of course. So we're not really going to massively go in here to checking the data quality, but you can see, of course, that data that in principle looks fine can have pretty big issues, namely, for example, participants not doing the task. So let's actually go into this participant 2 a little bit more, right? Here we see, okay, the count of the trials where the correct is 1 is almost nothing. Whereas if we look at everything, basically the participant completed the whole experiment. What does that mean then? You can ask yourself. Does it mean that the participant was really poor at the task and just guessing? Well, no, because if the participant is just guessing, then of course about half the trials should be correct, right? So you would expect the guessing, you would expect the accuracy to be about maybe to have about 36 trials correct. But whereas in actually there are only about 2 trials correct, and here even 0. So what happened, quite likely, that this participant was not responding at all, but just waiting for the trials to time out on every trial. So what that happens quite probably is that the participant went into the cubicle, started basically WhatsApping, waiting for the experiment to time out completely, and then leave and get the study credits, basically. That's quite likely what happened to this participant, right? And you want to actually inspect your data adequately before you actually decide that the data is valid. And now that I'm saying that, I think actually this is such an important point that let me put a link to a manuscript that I wrote together with Jennifer March in the chat that actually has some information about the various forms of checking data quality that you can use to verify this. Goes a little bit beyond what we have time to do here, and it's also a little bit complex, but it's nevertheless important. So I'm going to post it here. Up. All right, there you go. Okay, so now we have 2 pivot tables that we created. One for our, so actually you cannot save a pivot table as a CSV file. So what I just tried to do doesn't work. You have to save it as an Excel file. So I'm going to call this, this is not visual search, memory capture.xlsx. So now I basically showed you how to go from the online data to a pivot table and from the laboratory-based data to a pivot table. I think this is a good moment to take a short break. Later, we will take a slightly longer break. Then after the break, I encourage you all to actually conduct these steps yourself, either with data that you collected online or data that you collected in the lab, or data that Wisnu posted in the chat called Venus February 2022. But before we actually take a break, are there any questions about this up until this point? No? Then let's take a short coffee break. Wisnu, what do you say until 5 past? I have to do a time zone conversion here. Yep. Until 5 past 3 or until 10 past 3? How much time do you think?
Yeah, I think 10 past 3 is better.
10? All right. Then I'll see all of you back.
12-ish minutes.
Yes, in 10 past 3. Oh, it's nice actually. I can see you. Sorry?
10 past 2 here. So we'll see each other again in 12 minutes. So look at your own.
Yeah. Yes, exactly. All right.
See you.
All right, welcome back. I see now actually that we diverged a little bit from the schedule by taking a short break already at 2, and I called it 3 because I was 1 hour. Right, so actually it's only 10 past 2 now for you, Vishnu, not 10 past 3. Yeah, okay. So,
it's fine. People are having snacks too, so
okay, no rush.
Happy. Unfortunately, that's something that I can't send all the way up to Coney.
Mm.
So I think whenever people are ready to continue, we can just continue. So I was just busy creating an R version of the thing that you just showed everyone, in case people want
Okay,
R.
that would be good. Can you maybe share that in the chat also?
Yep, I'll do that.
Okay, so in the meanwhile, thanks. I'm sharing my screen, and as always on the website, the Venus University, the Venus Workshop website, you can download the slides And then that is in this case especially interesting, probably because you can actually see the steps that I just showed you back on the slides when you try to do it yourself. So my my suggestion would be that now for the hands-on part of this this workshop, it's a bit more open than previous times because we don't really have like a specific tutorial for this, but it is nevertheless important to practice with this. So I would say now choose whether you want to actually go and download something from JTools and process it up to the point of a pivot table, as I showed, or that you start from some participant data. Now, Vishnu posted the data in the chat that you can use as well. This data is actually downloaded from JTools, I can tell, but as separate participant files. So it actually shows yet the third option that I don't normally actually do like this. But basically, I correct me if I'm wrong, Vishnu, but you sort of cherry-picked individual participants files from JTools and downloaded them separately converted them to CSV files. And now they are all separate CSV files. Is that correct? That's what you did?
No, I did the other way around. So I have the merge data version first, converted from OpenSesame. But in case participants want to try the merging themselves,
yeah, they should.
One big file, I just separated for each participant.
Ah, okay, okay. So if you want to use that data set, I would say you will open it and you will see that there is one large data file in it called Simon data that's already merged. And there are smaller data files for the individual participants. And then merge those smaller data files into one larger data files based on the modification of the script in Python or in R, and then create a pivot table. Can you tell us maybe also, Vishnu, then of course it's also important to know what the dependent and the independent variables are here.
So the dependent variable in this case is the correct the response time. It's called response time. Sorry, let me check it this in case I was wrong. It's called response time target keyboard response. Super detailed. And the condition. So this was an assignment test. You saw an arrow. It could point to the right or to the left, and the arrow could be positioned to the right or to the left on the screen. So incongruent means that the arrow is pointing to the right, but it's shown on the left side of the screen. So we have incongruent condition and a congruent condition. When the pointing of the arrow is consistent with the side of where the arrow was shown.
And that is the condition variable.
That's the condition. So and there is a participant ID variable. It's called JTools. Wait a minute. It's called JTools study result.
Okay.
And this is the experiment most of you, if not all of you, have participated in February.
Okay.
The demo experiment that I showed you in February.
Okay, so let's. My suggestion is let's work on this until 3. In the meanwhile, because I'm here also ready for open for questions, ask me if you get stuck, but also ask me if you have more specific questions that we haven't covered here. Because of course, this kind of data analysis is part of the steps are always the same, basically what I showed now. But in many cases, there are also exceptions, of course, that depend on the specifics of your experiment related to filtering or what have you. Or maybe you want to actually prepare your data for a different kind of analysis. So I'm also open to any kinds of sort of more free questions right now. Do you think 3 until 3 is good, Vishnu, or is that a bit too long? Yeah, you think it's good? Okay. So get to work. Choose a data set and parse it up until the point that you have a nice pivot table. That is the goal to achieve for this section of the workshop.
And in the meantime, I'll help participants who are sitting with me here in the conference hall. But for those of you who are at home, feel free to drop a message to everyone. So either Sebastian or I will help you.
Absolutely. Yeah. And it's really fun actually to see all of you working in the big. I couldn't see that before with this kind of camera, but can now.
So some people are having problems with, so CSV means comma separated values. And sometimes your Excel setting or your data spreadsheet setting is not, it's not typical. Then sometimes it's a tab separated, or sometimes it's semicolon separated and so on. So
Let me,
yeah.
shall I show how that works?
Yeah.
Exactly. Yeah, okay.
I'll Google the tutorials for like text to column thingy.
Yeah. 1 second, and I have to log into my university workspace where they have, they use Windows, and thus I can show Excel, but it's true, and it's super annoying.
And just in case you're wondering, the CSV format is also the format that JASP understands.
Yeah.
So for the analysis, yeah.
CSV is de facto sort of the standard text-based spreadsheet format, which makes it all the more surprising that Excel doesn't just, at least not all versions of Excel, I think it varies on version, but doesn't always open it as properly, basically. Okay, so I'm sharing my screen now. For those of you who want to actually open a CSV with Excel and who get stuck. So basically here I have merged data.csv, and I can just open it in Excel. Right click by saying open, right, and then it will launch Excel here on my university computer. And then what will happen is the same as probably happens for lots of you, namely that basically it separates the lines, but it doesn't actually separate the columns. So all the column headers are kind of ugly, stashed here, and then looks horrible, basically. Now, what you can then do to change it, to actually properly parse it, is you select the whole column. So I click on A, bam. Then I go to data, the data tab, and under the data tab, you will find a thing that says text to columns. And if I click on this, that allows you to actually sort of properly import or properly format the data. So text to columns, okay. Then you have a text wizard. It's a bit small, but I'm sure you can, if you do it yourself, you will see it as well. Basically, it asks you what the format is of the data. It should know that because it's a CSV file, and that is always formatted in the same way, but it nevertheless asks. And it asks whether it is delimited, meaning whether there are characters separating the different cells, which is the case, or whether it is fixed width, which would mean that every cell is sort of padded with spaces until they're the same length, which is almost never happens. But so I say delimited, next. Then you can indicate what the delimiter is, so what the separator between the cells are. Well, it's comma separated values, right? So it should not be a tab, but it should be a comma. That's what I select. Then you see it starts getting, and then then you see in the preview that actually if you select that it gets parsed properly. Up, and then I say okay, finish, bum, and then we actually end up with up. Oh, this is actually, so this is not a good example because I opened not the original data file, but I opened the pivot table that I created. But you see, regardless that it's not the original data file, but the pivot table, you see that I now actually imported the pivot table and I can represent it here in Excel, right? So the main thing is select the column, go to data, text to columns, choose delimited format, and as a delimiter, choose a comma, press finish, and then that's it. Those are the steps that you need to take, basically.
Apparently, some people are still having problems because sometimes the column skips. So what I'm going to do for the assignment data is just going to send, I'm going to create an Excel file with an XLSX format, and then you need to save it as CSV for later analysis. I think that's the easiest way.
Okay, if you say so, yeah.
Curious, like for those of you who are at home, are you okay? So are you with Shruti and Melly? Are you having troubles with the data exporting or parsing? Are you okay? Melly is trying. Feel free to share your screen and show it to us so that either Sebastian and I will help you with the data transformation thing. And I just send you the Excel file for the assignment data. It should open correctly with Excel. I don't know if you try to open it with LibreOffice or anything. But before you can use it for analysis later, so try to create a pivot table with it in Excel if you want to. But for the analysis later, you need to save the file as CSV for JASP.
Yeah, that's true. Actually, we will need to do a few more things with the pivot table before we can actually open it in JASP. We'll take a look at that after the break. So.
I see that in the chat, Melly wants to see the result of the pivot table. Do you want to show it again, Sebastian?
Oh, okay.
I think it's
Can I
not
see
the ones that
Yes.
you showed before.
So Melly, which, well, I will show both pivot tables actually, and then, sorry, I missed the chat message. Okay. So let's take a look first at the visual search data. So what I did here is create so what does the data look like, basically? How is it organized?
I think
Well, we have
other monitor, Sebastian.
Am I sharing the wrong one?
We're seeing your calendar at the moment.
Oh, okay, yeah. Up. All right. So what do we have on the sort of the thing that we use to actually define our participants is the variable JTAS result study ID. So that separates the rows. And the thing that we use to specify the columns is the set size variable. So that specifies the columns here. And then for every combination of set size and JTAS study result ID, we have two things, namely the average of the correct variable, that's shown here, and the count of the correct variable, which basically just indicates how many trials there are. And both are important, right? Because the average is our dependent variable, and the counter allows us to see whether the participants actually completed the experiment, or, such as is the case for this particular JTAS study result ID, a lot of the data was missing, basically. Now, so that's what we are seeing here. And how do you specify it in LibreOffice? So as the row fields, I indicated JTAS study result ID. As the column fields, I indicated set size. And as the data fields, I indicated the average of the correctness and the count of the correctness. Does that clear things up for you, Melly?
This is okay.
Yeah. And exactly how this works depends, is a bit different for the different, maybe I can also show, just because I don't really have much to do. Let me show what this looks like when you do it in Google Sheets. So, up. All right. So first of all, of course, here you need to actually, I have my Google Drive here, and then I say, okay, I'm going to upload the merged data, for example, which is the large data, the large data set. Oh no, wait, actually, this is not. Let me be a little bit more up. Okay, so what I will do, I will upload the visual search data, and then I will actually recreate the pivot table in Google Sheets in basically the same way as I did before with LibreOffice Calc, but now using a different piece of software. So I just open it. And Google Sheets is pretty sweet, actually, I think, for these things. Up. Okay, I don't necessarily need to take a tour. Right, so it's actually here we have all the data. So this what I'm looking at now is the visual search data after I've downloaded it from JTOS, and with the conversion utility in OpenSesame converted it to a spreadsheet. And then I just say data up or form way tools. I have to find where the pivot thing is. Insert pivot table.
In Excel is also under insert.
Ah, okay. Insert. I want to have a new sheet, create. Up. And then it has essentially the same, you need to specify the same things as you need to specify in LibreOffice, but of course everything works slightly differently. So for the rows, I say, okay, let's add, oh, not Q, add the JTOL's result ID. That's what we need to have for the rows. For the columns, we need to add set size because that's what specifies our columns. And for the values, we need to specify correct, but not the sum, but the average of the correctness. And then actually it makes sense, as I did before, to also for the correctness provide the count so that we can actually see how many trials there are. Now, and then we have the exact same pivot table, but this time created in Google Sheets. Up.
Again, for those of you who stay at home, you can also share your screen. So that's another possibility, just to show if you're getting stuck somewhere, share your screen. I allowed already all participants, everyone to share screens.
Hello, Mr. Sebastian.
Hey.
Okay. I will kind of encounters an error while I'm trying to merge the data.
Okay.
So I can maybe I can share my screen. Yeah.
Let's do that.
So based on what you type on the chat, this is the variable that we need to merge in one file. Is that correct? Okay. So I save the data from Mr. Wisnu as the Simon data. So I have to change this role as to Simon data. Is that correct?
It is not really correct because it assumes that the data is in a subfolder relative to your script. So right now you see that your merge data is in the same folder as the participant data files. So what you need to do is, why don't you right click on the Simon data thing? And then you say new and you say folder or directory. And then you call it subject data, for example, or data, doesn't really matter. And then you move all the participant data files there. So you can select them and then say cut. So select all of them, right click, cut. And then you right click on subject data and you say paste. Okay. Yeah, it's a bit not very convenient. You have to say okay for everything. And now you see basically that in there you have the subject data. And now you can say source folder is subject underscore data. And that will be correct because it is now relative to the merge data script, if you see what I mean. Okay, save and run.
Okay,
There are
I
still,
could have missed this step. Okay.
yeah, but there's still something that is incorrect actually. So look at columns to keep. You see that you have a comma after condition, but not a comma after JTOL study. All right.
That's it. Okay. So I have to run again.
You have to run again. Up, save and
Save
run.
and run. Okay.
And let's
And
now
then?
take a look. If you now click on merge data, and then you can also say load into workspace, then you immediately get a nice view of what it looks like. All right, so now we have JTOLs. Yeah, okay.
Okay.
You see now you get kind of like a spreadsheet view, but then in Rapunzel.
Yeah. Okay.
All right.
Okay. Thank you, Mr. Sebastian.
Yeah, you're welcome.
So one more question. I actually jumped the step, so I have already merged the data using the merged data from Mr. Wisnu. Is this supposed to be the result of? Can you see my Excel screen? Is this supposed to be the result of the pivot table?
I think so, right? So you've used as the row the result ID, the congruent and the incongruent are the response times. They seem very, very high though. So I think you probably took the sum. Yeah.
Okay.
So then you can edit it. And then instead.
Edit to.
Can right click maybe.
Right click.
And then pivot table options.
Pivot table, okay.
Oh no, sorry, this is not it. Cancel. Show. Oh yeah, summarize values by, now it says sum and you want to have average.
The average,
and,
okay.
And that seems more realistic, right?
Right. Okay. Thank you, Mr. Sebastian.
Yeah, you're welcome.
Okay.
Hi, Simon. Sebastian. So sorry. Hi, Sebastian. Sorry. So immersed with the Simon data. I forgot to call you. Okay. So I'm just want to clarify the steps to run the Python code. So first you need to put the folder inside the OpenSesame folder, right? Okay. Is that right? Because I'm just wondering, I see Melly's screen and she already have her data in the OpenSesame.
Let me show you.
Yeah, thank you.
All right. Right. Okay. Share. So there is not really such a thing as an OpenSesame folder or something like that. That's why I just to clarify things. What you want to have is you have your script that does the merging. In my case, it's called merge data, and I just put it in my downloads folder. Then there is a subfolder which I called subject data, And that is where all the participant data files are now. So that is the main thing to have. You need to have your folder, your file, merge data, and then a subfolder that contains the actual participant files. And then in Rapunzel, that you see here on the left-hand side, you see that this is just a different view of the download. So if I put them side by side, you see that here what I did is I'm viewing my downloads folder in Rapunzel, but it's the same as here, right? It's just a different software to view the same thing. And then inside the merge data script, you indicate the name of the subfolder, so subject data. So this folder should not be the folder that merge data.py is in, but it should be a subfolder relative to merge data.py. Does that make sense? Yeah?
Yes, thank you. Yeah, yeah.
Okay, good.
So
And I understood that there were some issues basically with converting the files to opening the files in Excel related to the fact that there were semicolons used as separators rather than commas. So that is a bit of a, well, it's a bit of a hassle sometimes, right? You have to kind of know exactly how the data is formatted, and probably Wisnu at some point chose to save it as semicolon separated values instead as comma separated values.
So if you have problems with that, what I figured is that instead of opening the Simon data directly, just open Excel and then click data, and under data, choose get data from text or CSV, and then it loads just correctly.
Oh, okay. Yeah, you can do that too. Yeah.
So instead of opening the data directly, you just open Excel and then practically import the data to Excel.
Okay. Gimana sih navigating ini, kenapa bisa ganti-ganti OpenSesame? Bingung aku belum.
And again, as a reminder that Sebastian is only with us for today, but I'm always here. So the next couple of days, you want to try things out and you get stuff, you can always contact me, and then I'll try to help you as well. So I think the main point for today is to try first to get familiar with the steps. So it's not as straightforward as just putting a data manually and then analyzing it to SPSS. So we got the data already, but it needs to be formatted in a certain way. And today we're learning those steps to format the data in certain ways that JAS understands or SPSS understands.
Exactly. Yeah. And after the break, we will get to the actual analysis. So who actually managed because it's a bit difficult for me to keep track, of course, of who's where. If you actually managed to create a nice pivot table, can you give me a thumbs up? Okay, good.
Not sure if it's right, but bener lah ya. Kira-kira. Iya, gimana? Nah, itu.
We got a question here. So in Rapunzel, do you need to set up the working directory first, or it just assumes that whichever folder. You put the Python script in, it's the working directory?
Yes, it by default. I can show that. So let me also explain what the working directory is. This is not trivial to everyone, of course. So in Python and in general, the idea of a working directory is sort of the place in which the commands or your script lives. And all the names are always relative to the working directory. So if I here say the name is subject data of my source folder, that implies, because subject data lives in the downloads folder, that will only work if the downloads is actually the working directory, sort of the starting point. And you see that my merge data.py is in downloads. And by default, basically, Rapunzel just makes the working directory the directory in which the script lives. If you click under preferences, you can actually change, define that behavior. But generally speaking, it says here, change working directory. So it's generally speaking, that's what people want, basically.
Since I'm not too familiar with Python, is there a command that you can put in console to just check your working directory?
Yes, you can say import os.get c. So import os. OS is a library for operating stuff, operating system stuff, and get cvds, get current working directory. And you can also in Rapunzel say under run, there is change working directory to active file, and it will actually do change the working directory, but it will do that by default every time that you run the script anyway.
Kita simpan di dalam participants datanya ya.
And can you also provide the link again to the tutorial part in OSDA, where
Yeah.
you, yeah, thanks.
And on the slides, all the links are also provided, right? But here it goes up.
Oh, itu juga salah sama. Bentar, lagi baru nggak.
There they are.
Coba ya. Tadi gue bingung. Coba dulu. Rapunzel rambutnya panjang sih. Ya terus tadi resolve, tapi harus sama persis tulisannya, takut salah nih. Ya terus condition terus
Kalau bisanya
karakter response satu lagi kita harus save dulu Python-nya ya, baru dia bisa itu kan, save-nya di folder yang sama-sama file partisipan.
Okay, so my suggestion is if to take a 30-minute break now, so our longer break. But before we do, let's make sure that we're all on board with actually creating the pivot table, so that after the break we can go from the pivot table and actually conduct a repeated measures analysis. Who needs a little bit of help, final help with the pivot table? Are you all good? Vishnu, is all good on your side? Do you think it's a good idea to take that 30-minute break now?
Yeah, so everyone who's joining me on site, they're all having pivot tables, so all is good. So for those of you who are at home, Melly and Aryu, Melly is good, Aryu?
All right. So then let's say that this time actually really, I have your time correct. Let's say we reconvene at 30 past 3, 15:30. And in the meanwhile, so after the break, we will do something that's pretty simple, actually, namely conduct a repeated measures analysis. This is not going to take so long. I also want to have some time for a Q&A at the end, of course. It is if you have specific questions about different kinds of analysis techniques, that's also, you can also ask them then, right? If you want to ask about a linear mixed effects model or different kinds of between subjects and ANOVAs, etc. But in any case, we will focus on the repeated measures analysis. So I will see you, all of you, in 30 minutes, and enjoy your break, and see you in a bit.
Foldernya bisa subfolder kan ya? Gue bingung kok nggak bisa ininya. Nih, participants data ini.
Kalau lu tulis lagi import spasi OS, tapi data file enter, terus os dot get cwd dalam kurung get cwd dalam kurung.
Gini.
Enter. Oke. Nah, yang terjadi adalah si komennya itu ada di folder ini kan?
Komennya ada di folder ini?
Oh, nggak boleh.
Oh, itu yang salah gue. Komennya harus ada di
Komennya
folder
di
yang
folder
ini.
beda,
Bisa gue pindahin langsung nggak?
Karena ketika dia bilang baca semua isi folder ini,
Oh.
ada satu file yang isinya tuh nggak sama dengan yang lain.
Gue coba pindahin. Ini bisa dipindahin dari sini atau?
Buka aja di
bisa ya?
file explorer.
Oh, oke.
Nih, sama lo kasusnya kayak tingkat.
Iya, iya, iya. Oke.
Dia kan akan buka si folder partisipan ini. Dan dia akan merge semuanya. Tapi begitu dia lihat, tek, kok ada satu file. Jadi dia
Ya,
merge
ngerti.
itu nggak boleh di folder.
Itu gue ngerti yang tadi dia bilang apa? Ini belum dilihat. Ini filenya harus berada. Apa tadi dia bilang di folder yang sama. Tapi jadi file komen sama folder partisipannya harus ada di dalam folder yang sama.
Ya, itu juga.
Oke. Yang tadi gue belum paham adalah ini basic banget yang saya kayak beginner question. Kita harus buka dulu filenya, save dulu, baru run ke situ. Gue kira kayak run aja, lari-lari aja, nggak ada tracknya gitu. Oke, udah. Jadi kawan-kawan
ini tuh aku juga belum dong karena Python kan aku biasanya pakai R.
kalau udah di run.
Bisa nggak? Di run ya semua.
Oh, dipilih dulu ya. Dipilih. Ya, ada lagi salah.
Oh, bisa.
Udah.
Ya udah. Harusnya sekarang udah ada.
Nah, ini ada di mana berarti?
Udah ada satu file di folder participants. Di folder binus Februari 2022 yang namanya merge. Ya kan?
Yeay! Iya, kita belum ada deh. Right. Belum ada. Merge. Gue nggak keluar si asli gue. Ups.
Hi, everyone. Are we kind of ready to resume?
So some people are still having prayers. I think if it's okay, let's wait for 3 more minutes.
That's fine. Just give me a signal when you think everyone is ready to resume.
Lulu, Farah, siapa lagi? Ini aku. Pingkan sholat juga. I think we're ready to continue.
Good. Well, welcome back, everyone. So let me share my screen for a very short mini presentation. So what we're going to do now is basically take the pivot table that we created before the break and load it into a statistics program called JASP to perform a statistical analysis. So what is JASP? JASP is a free software package for doing statistics. It's actually developed in Amsterdam at the University of Amsterdam. So very Dutch-focused open source software here. And it is a graphical user interface, a little bit like OpenSesame, but for statistics, of course. And it is based on R. So it is a little bit like a graphical front end to doing analyses in R. It is also very strongly focused on doing Bayesian statistics. So what is quite nice is that for every kind of analysis that you can do in JASP, or at least most analyses, you can do either sort of the traditional p-value analysis, null hypothesis testing. That's actually what we will do here, because I think that's what most people do. And you can also do a Bayesian analysis where you get your statistics expressed in terms of Bayes factors. Wisnu, is there? I know here in the Netherlands it's becoming more and more common to report Bayes factors over p-values. It's a bit fashionable. Is that the same also in Indonesia, or do you think it's better to stick with the p-values?
Well, let's stick with the p-values for now. I know that there's a growing interest in Bayesian analysis, but I don't think it's the norm yet to also report Bayes factors in addition to p-values. But the interest is growing. So, but today we're focused on p-values first, like the traditional null hypothesis testing. So
what do we need to do actually to do this? We need to first modify the pivot table, because annoyingly it has a few things that stand in the way of directly loading it into JASP. Basically, we need to go to a format where we have only one row with column headers, so that it's a proper CSV file again. And then we open it in JASP, and we're going to conduct a repeated measures ANOVA. Now, what is a repeated measures ANOVA? I'm sorry if I'm being sort of over-explaining things. I just don't really know sort of the background that you have in statistics. But a repeated measures ANOVA is an ANOVA, an analysis of variance, for within subject designs. So the kinds of designs that we focused on here, where every participant participates in all conditions. If you have a between subject design, right, where every participant is in one specific group, right, you have an experimental group and a control group, you would do a regular ANOVA. But we're going to do a repeated measures ANOVA, which is the same as an within subject ANOVA. They're the same thing. All right, so let's get to work. So let me actually open the pivot table that I made for the data that Wisnu uploaded and that many of you have been working with as well. Right, so what I did, just as a very brief recap, for the rows, I selected the JATA study result ID. For the columns, I selected the condition, which can be congruent and incongruent. And then we have 6 participants with these conditions, and we have the total below and the total result here. Now, let me actually really just copy these values. I will create a new spreadsheet. Oh, oops. And I will paste the, I will say Control Shift. Values only. And I will paste it as a new spreadsheet here. I hope that makes sense. And we may run into exactly how to do this in Excel later on, and then we'll help all of you with this. But the idea is we just take the original pivot table, and this pivot table is kind of like a special object, right? Where you can click and you can do all kinds of things from it to it. And here I just copy and pasted the values into a new spreadsheet, and now they're just text. There's nothing special about it. Now here at the top, we have one row that actually indicates some kind of metadata, right? It indicates that we have the average response time for the cells and that we are going to, we don't need that because it is basically, it makes our CSV file invalid. We want to go to a format where we have only one row with column names. So I say, delete rows. Up. Now at the bottom, we have a similar situation. We have a total results, and that this kind of summarizes the results. Now, this in principle is a valid CSV file now, but it will pretend that the total result is like a new participant with the participant ID total result. And that will of course make our results invalid because this is just a total and not an actual participant. So also for the bottom, I select it and I say, delete rows. Now here we have on the right-hand side, we have a total result column. That in principle doesn't hurt anyone, so you can leave it if you want. But we don't need it for the analysis. But we're going to leave it anyway. So now we have a nice pivot table of the format that you can load into JASP. And what is important is that there is one row that has the column headers and the rest are the values. And there should not be like a total at the bottom, and there should also not be like an additional row yet at the top. So I'm going to say save, and I go to save. Oh, I will call it, I will call it Venus pivot table.csv. Don't save it as an Excel file, save it as a CSV. Oh. And then I say save, use text CSV. Here you can indicate in LibreOffice, you can indicate a few things of how exactly you want to save it. But I'm just going to go with all the defaults, and then you get a nice comma separated value spreadsheet. Okay. Are you with me so far? Is there anyone who has questions about this? What we've done now is just some very basic sort of turning this nice pivot table from Excel and saving it as a plain text CSV file. That's what we've done now. All right. Then I go to JASP. I'm assuming that all of you have installed JASP actually. And then I'm going to open this file. Show, open, computer. I'm going to browse from my downloads folder. And I called it Venus pivot table here. So I'm just opening it. And now it will open it in JASP. This is a view of the data. And now we want to, of course, perform an analysis. So I'm going to click on ANOVA. And here you see, as I mentioned, that JASP offers for lots of tests, sort of what they call classical tests. The tests that give you p-values or that give you that are null hypothesis testing, and then Bayesian equivalence at the bottom, right? So they have that for all of them except for a MANOVA, which is an ANOVA with multiple dependent measures. But what we're going to do is just a regular classical null hypothesis p-value repeated measures ANOVA. But now, then for a repeated measures ANOVA, you need to specify the design. And this goes in a bit of a funny way. But basically here, under repeated measures factors, you have to specify all the factors and the levels that we have. In this particular situation, we have a very simple design with only one condition, namely called condition, with two levels, congruent and incongruent. So I can here just say condition, or I can call it congruency, whatever. Condition is always a bit of a poor label in a way because everything is a condition, right? It's not super descriptive. Congruent and incongruent. Oh, oops. Condition incongruent. And now you see here at the bottom that it says repeated measure cells, one for congruent and one for incongruent. And now this is a bit, once you've done it once, it's quite intuitive, but the first time it's a bit weird. But what you need to do is basically just select the two columns here on the left-hand side, right? You see all the columns that exist in the data. So if I put them side by side, can I do that? You see that basically here, these are the columns that exist here in the data, right? So nothing magical. And you just take the two columns that actually define these two factors in our repeated measures, I move them in there, and then it starts conducting the repeated measures ANOVA. That's it. And then how do you interpret the repeated measures ANOVA? Well, basically, you look mainly at the top here. There is one within subject effect condition. The F value of it is 5.8788, and the P value is 0.06. So we have a trend towards an effect of congruency. And then the question is, of course, what does that effect look like? Can we also create a nice plot? Yes, we can actually. We can say under plots, descriptive plots here. At the bottom, you have lots of options for every test. Descriptive plots is a very useful one. And then you just say, okay, we want to create a plot that has error bars. On the y-axis, it's reaction time in milliseconds. And the factor condition should be on the horizontal axis. And then we get a plot where we basically visualize the result. So condition, congruent, incongruent, reaction time on the y-axis. We have our 95% confidence intervals, and they overlap a little bit, but not that much, reflecting that we almost have a significant congruency effect. Does that make some kind of sense? Is everyone with me?
Yep. So what I just added in the chat is because we are using JASP as the formal statistical application for statistical testing in our program here, and we have made several tutorials. So it's in Indonesian, but for the participants here, it's you can check it out in the links that I just sent in the chat. Another thing that you notice is that for us experimental psychologists, we typically just go straightly into repeated measures ANOVA. But I know that some of you are teaching statistics, and you might ask, well, why don't we use t-test instead? But you can also see that the p-values are similar. That it's just the same test. It's just the formula is a little bit different, but it serves the same purpose.
This is a very good point, actually, Wisnu. So the reason I'm using repeated measures here is because next thing that I want to do is show a slightly more complex use case that you need a repeated measures for. But this specific example could be done with the paired samples t-test, and it would give the exact same result. So how would you do that? T-test, classical paired samples t-test, and then you say congruent versus incongruent, variable pairs. And the t-value would be different because the t-test gives a t-value and not an f-value, but the p-value is always the same. So indeed, a repeated measures ANOVA with a design where you have only one factor with two levels is identical to performing a paired samples t-test. Absolutely. All right. Are there questions about this before we move into a slightly more complex scenario of a 2x2 repeated measures design? I see one thumbs up. That's not a question, I guess, but just an indication that you are good to go. Okay. So this is a relatively simple use case. So let's go back, actually, and go back to the memory capture data that we created before. So here we have a more complex pivot table. And that pivot table indicates two factors, target match and distractor match. And we also keep track of our counts, our cell counts. And we have considerably more data here. Now, what do we want to do here, actually? Let's go and take a look at this. So first, I'm just going to select all of this, and I'm going to create again a new pivot table or a new spreadsheet, and I'm going to paste everything, and I say values only to get rid of all the stuff that we don't want, basically, right? All the sort of the formatting and the fact that this used to be like a specific pivot table object, etc. And now it's just text and nothing special, just text. And now at the top here, we had our two rows that correspond to our filter. We don't need those because we want to go to a format that has only one header. So I do up, delete rows. Then here we have two conditions. We have target match and distractor match. And they're coded such that here this is target match 0, distractor match 0, target match 0, distractor match 1. target match 1, distractor match 0, and target match 1, distractor match 1. And we need to actually put this information is now spread over no less than 3 rows. So we need to actually go to turning this into only 1 row. How can we do that? Well, we can say, for example, target match, distractor, non-match. Oh, sorry, target non-match, distractor,